Hey everybody, so we're going to be talking about triangle midsegments today. Now what a triangle midsegment is there we go. It is a segment connecting the midpoints of two sides of the triangles. So for example, point D is a midpoint here, and so is point E of a midpoint. We can tell that by our congruency markings. All right, so at that point, we can say that segment DE is the midsegment of triangle ABC. Now, with that comes a theorem, all right? So, if a segment joins the midpoints of two sides of a triangle, then that segment, the midsegment, is going to be parallel to the third side, and it's going to be half as long. So pretty much, if I were to use the same diagram from above, if DE was a midsegment of triangle ABC, then what we can say that AC and DE are parallel by the triangle midsegment theorem, and that DE is going to be half of AC. Or you can also say that AC is 2 times DE. Pretty much, this is going to be 2 times as large as that. So let's identify some of these things first, and then we'll go ahead and solve all these things. First off, we got to identify pairs of parallel segments. So you'll notice that W, X, and Y are midpoints. WX is a midsegment, and it's going to be parallel to SR. So, right here and right here, if that's helping you. I'm going to switch colors so that it can help you see better. We've got WY is also going to be parallel right here to QR. And then we've got XY is parallel to QS. So I want you to try number 2, pause the video, and I want you to come back and check your answers against mine. All right, now that you've come back, you'll notice that JL is parallel to GH, JK is parallel to FH, and lastly, KL is parallel to GF. Again, if you had done it LK is parallel to FG, that is totally fine, as long as they are corresponding, just like we've been doing. All right, so given all this information, we are now going to find the missing measures. So L, M, and N are midpoints of the sides of triangle PQR. That means these two are congruent, these two are congruent to each other, and these two are also congruent to each other. All right, PR, all of this is 46, which means this part is half of 46, aka 23. We're going to do the same thing here. With MN, we're going to use PQ right here, that is 40, which means half of that is 20, and that's what MN is going to be. Lastly, we're going to work backwards on this one, and they've given us that LN is 17. Well, that means this part right here is going to be twice as long, which is going to be 34. And then I've asked you about MR. Notice that this is being split into 2 congruent parts. Well, 34 divided by 2 equals 17. And I wonder if you see a relationship with LN, QM, and MR as well. All right, let's do number 4. So if F, G, and H are the midpoints of the sides of triangle CDE, so these two are congruent, these two are congruent, and lastly, these two are also congruent. We have that FG is 9. That means it's going to push out. This entire thing is going to be double that, which means it's going to be 18. And that tells us that DE is 18. Then we've got that GH is 7. Push it out. That's going to be doubled when you push it out, and you get 14 for CE. And then, lastly, we're going to do, let's see, what color do we want? Let's stick with purple. All right, we've got CD is 24. So all of this is 24, which means FH is going to be half of that, which is going to be 12. And then they've asked us for the perimeter of triangle CDE. So pretty much you are going to be adding up CE, you're going to be adding up CE, ED, and DC to get the perimeter. So 14 plus 18 plus 24. When you add that up, you should get 56. All right, now that you're able to identify them, you know what we're going to do. We are going to solve it. This time, no proving. I know, you guys are all so excited. So you'll want to remember that this part right here is half as long as this entire thing, meaning 2 of the 6x plus 31 is going to be the same thing as the 19x minus 36. So then all you're going to do is distribute and then move your variables and solve for x. So I get 12x plus 62 equals 19x minus 36. Then I get 98 is equal to 7x. And I got x is equal to 14. Done. Super that easy. Well, guess what? You also have those parallel lines. That's the second part of that theorem. So you can use that to help you find your different missing angles here. I'm going to start off with 127 here. 127, well, because we're looking for angle 1, you'll want to remember that these two lines are parallel, which means angle 1 and 127 are same side interior angles, meaning they're supplementary. And 180 minus 127 is going to get me a 53. All right. Well, guess what? We can use that to help us solve for angle 2 because those two are corresponding. And it's also supplementary to that 127. Now, I'd like to keep going to angle 3, but I can't because it's cut by another transversal. It's a different transversal this time. So let's go ahead and work with what we have. So I have 59, and that's going to correspond with angle 4. Well, you can figure out what angle 5 is because it's going to be supplementary to this. And so we get 180 minus 59, and that gets us 121 degrees. So we get that this is 121. And then lastly, we can use our triangle sum theorem for this last one. We can add up angle 2, which is 53, and then angle 4, which is 59, and whatever we get from that, which by the way is 121, and subtract it from 180, and that will be angle 3. And I believe, oops, that is not 121. That's where my math went wrong. So it's 180 minus 53 plus 59. That's going to be 10. Sorry. Oh my goodness, y'all. 112. There we go. And you could figure out all of those measures just by using those parallel lines. Yes, those alternate interior angles corresponding, same side interior, they're back and they're staying. All right, so this one we are going to be finding the measure of angle CBF and the measure of EFD. Now I've drawn these congruency marks because they're corresponding angles on this transversal. All right, so that means we can set them equal to each other and then solve for x. So I want you to pause your video, solve for x. You're going to end up getting x equals 9. You have to take that 9 and drop it into either one of them. Because remember, since CBF and EFD are congruent, they're going to equal the same thing. I liked this one better, so I did 9 times 9 plus 2. That gets me 81 plus 2, which is really just 83 degrees. All right? So we are just breezing past this, and now we're going to do the last ones, where we're going to apply everything all together. So if MN and NO and MO are mid-segments, meaning their midpoint, M, N, and O are midpoints of those points of the triangle, of those sides, all right? And then we are being asked to find the perimeter of triangle JKL. So we have to figure out each and every single one of them. All right, well, let's do it. We know that this entire thing, because the half of it is 49, JL is going to be twice that, which is 98. All right, this one right here is going to be twice 42, which is 84. And then this one, oh, we can't do that here. We have to solve. Oh, no. So it's going to be 2 times 6x minus 1 is equal to that 13x minus 10. Because remember, 2 of these add up to the entire thing here. So if you solve for x, you will end up getting x is equal to 8. Then you have to drop it back in. So we are going to have to do 13 times 8 and then subtract that by 10. So I get 104 minus 10, which means this entire thing was 94. Now I have to add up all 3 of these to get my perimeter of 276. All right, last one for number 9. I'm going to help you set it up, but I want you to tell me what you're going to get. Oops, can you see it? Oh, there you go. For your x and your y. Your perimeter will end up being 154. All right, if TU, UV, and TV are mid-segments, meaning these are midpoints. So draw your congruency markings of triangle QRS, and then you're going to have to find the perimeter of triangle QRS. Remember, I've told you it's going to be 154. You have to tell me what x is equal to and what y is equal to and how I got there. You have to show me the work this time. All right, thanks for watching.